Let's do the same thing in another example. We've got the function f of x equals x minus 3 over x plus 1. Step 1, find all critical numbers. So we have to find the derivative, set it equal to 0. This time I have to use the quotient rule. My u is x minus 3, my v is x plus 1. So u prime is 1, v prime is also 1. Using the quotient rule, I take u prime times v minus v prime times u all over v squared. I distribute, combine like terms, and I'm left with 4 over x plus 1 squared. So there's my derivative. When does the derivative equal 0? Well, the only way a fraction can equal 0 is if the numerator equals 0. And 4 is never going to equal 0. When is the derivative undefined? Well, fractions are undefined if the denominator equals 0. That occurs at x equal negative 1. Now, I'd like to note that x equal negative 1 is not in the domain of this function. We'll come back to that a little bit later. So where's the function increasing? Where is it decreasing? Find all local extrema. I'm just going to put the negative 1 on my number line. I'm going to pick test values on either side of negative 1. And I'm going to take those test values and plug them into my derivative. When I plug in negative 2, I get something that is positive. When I plug in 0, I also get something that is positive. So that tells me that this function is increasing in both of these intervals. Now, negative 1 is not in the domain, and so negative 1 is actually not a place where this thing is increasing. So when we write our answer in interval notation, it's negative infinity to negative 1 and negative 1 to infinity. We are not including the negative 1 as part of our answer. Where's the function decreasing? Well, it's never decreasing. And are there any local extrema? No, for several reasons. If it's increasing and increasing, it's never changing from increasing to decreasing, so there can't be a max and there can't be a min. In addition, my only critical number is a place where the function is undefined. It's not in the domain. That's an asymptote. That's not a point on the function, and so that cannot be a max or a min. All right, one more example that's similar. Find all critical numbers. So that means I have to find the derivative. I'm going to get 2/3 x to the negative 1/3 minus 5/3 x to the 2/3. I am going to rewrite this using positive exponents. So the x to the negative 1/3 moves to the bottom. And then I need to figure out, where is this derivative equal to 0? Where is it undefined? To help me do this, I am going to combine these two terms into a single fraction. So I'm going to get a common denominator. I'm going to use 3x to the 1/3 as my common denominator. And so now I've got 2 over 3x to the 1/3 minus x to the 2/3 times x to the 1/3. We can add the exponents. 2/3 plus 1/3 is 1. And so that becomes just a minus 5x in that second term. So my derivative is 2 minus 5x all over 3x to the 1/3. Now, if I want to know where is this derivative equal to 0, the only way a fraction can equal 0 is if the top equals 0. So I set the top equal to 0, I solve for x, I get x equal 2/5. And then I need to figure out, where is the derivative undefined? A fraction is undefined if the bottom equals 0. If I set the denominator equal to 0, I end up getting x equals 0. So I have two critical numbers here, x equals 2/5 and x equals 0. Now if we want to figure out where is this thing increasing, where is it decreasing, we are going to make another one of those tables. I put my critical numbers into my table, and I pick test values within each interval on that table. I'm going to take my test values, plug them into my derivative, and see what I get. I might use a calculator to help me with this one. If I plug in x equal -1, my derivative is going to be negative. If I plug in x equal 1/5, I end up getting a positive number. And if I plug in x equal 1, I get a negative number. That tells me the function is decreasing, increasing, and decreasing. So where is the function increasing? That's where that derivative is positive. So everywhere from 0 to 2/5. Where is it decreasing? That would be where my derivative is negative. So negative infinity to 0 and 2/5 to infinity. And then finally for the local extrema, it looks like we're going to have both a min and a max. The min occurs at 0, the max occurs at 2/5. Finally, I need to give the y-coordinates of those points. So I take 0, I plug it into my original function, I get 0. So my min is at 0, 0. And my max, I take 2/5, plug it into the original function. I put this into my calculator, and let's see, rounding to the nearest hundredth, I got 0.33. Now, if you were to graph this function, because x equals 0 is a place where the derivative is undefined, there should actually be a sharp point on the graph there. Whereas at x equal 2/5, that's a place where the derivative is 0. So that would be a place where there's a horizontal tangent line. Okay, one more example. In this last example, we're going to think about things a little bit differently. We are given the graph of the derivative of a function. And we're going to try to answer the same kind of basic questions here. So if this is a graph of the derivative and we want to find the critical numbers, those are places where that derivative equals 0. Places where that derivative is equal to 0 on this particular graph would be at x equal 3 and x equal 8. Now I'm going to pull this information into my table with my number line just to help me visualize what's happening. Where is the function increasing? They are asking us about the original function. We are not given its graph. We're given the graph of the derivative. And so based on this information, based on this graph, I can see that the derivative has positive y values, is above the x-axis up to 3. Then it has positive values again from 3 to 8. After 8, it has negative y values. Because this is a graph of the derivative, the positive y values tell me the function is increasing. The negative tell me it's decreasing. So where is it increasing? We're going to say from negative infinity up to 8. Where is it decreasing? From 8 to infinity. And as far as local extrema, again, I'm going to look at my table that I made. I have a max at x equal 8, and my other critical number, x equal 3, is not a local extrema. All right, that's it for lesson 10. As always, let me know if you have any questions.